this problem, we're told we need to prepare 100 milliliters of a buffer solution with pH 4 using 0.1 molar benzoic acid, which has a pKa of 4.2, and 0.120 molar sodium benzoate, which of course is the conjugate base of benzoic acid. All right, so clearly I need to use the Henderson-Hasselbalch equation here. I know what pH I'm going for. I know what the pKa is. And when I rearrange my equation by subtracting 4.2 from both sides, I get negative 0.2 is equal to the log of the concentration of the base compared to the concentration of the acid. Now, I want to know what my base to acid ratio is going to be. So what I want to do is I want to take the inverse log of both sides of my equation. I'm going to take the inverse log of negative 0.2 and the inverse log of the base to acid ratio. And I forgot to include right here, there should be, I don't really have anything I can write with here, but I should be taking the inverse log of the log, okay, and that will then give me the concentration of base to acid. And the inverse log of negative 0.2 is 0.630957. That's what my calculator tells me. So what this means is my concentration of base to acid must be 0.630957 to 1. So now I have something to work with. In my 100 milliliters, my concentration of base to acid must be in this ratio. Now, what I'm going to work with instead of concentrations is actually moles, because in this solution, there's going to be an overall volume of 100 milliliters, which is 0.1 liter. And if we look at the concentration of base to the concentration of acid, my volume actually cancels out. And so what I'm going to be looking at is actually my mole to base ratio, which will be the same, 0.630957 to 1. All right, now I want to remember that in solution, my moles is equal to molarity times liters. And I know that my overall volume is going to be 100 milliliters or 0.1 liters. And I know that my volume of the acid plus the volume of the base has to equal to 0.1 liter. So I can express one as the difference of another. So for example, the volume of my acid would be 0.1 minus the volume of my base. Now what I'm going to choose to do is I'm going to choose to call my acid X, and then the volume of my acid X, and the volume of my base 0.1 minus X. So here we are, knowing that these two volumes have to add up to be 0.1. All right, so let's look forward. So again, I'm trying to get a mole of base to mole of acid ratio of 0.630957 to 1. All right, so I look back at what I have. My moles of acid is going to be 0.1 molar. That's the molarity that was given to me. 0.1 molar times the volume, which I'm calling X. And my moles of base is going to be its molarity, 0.120 molar. Again, that's what I was given, 0.12 molar, times its volume, which is going to be 0.1 minus X. And then what I do is I distribute my 0.21 over the 0.1 minus X, and I get 0.0120 minus 0.12X. So here, I know that my base to acid ratio is going to be this. I got that from my Henderson-Hasselbalch equation. And here I have expressed my moles of acid and my moles of base in terms of the molarity and the volume that I'm going to use. So up top here, I have my moles of base, which I calculated right here. And down here, I have my moles of acid, which I put right here. So I know that this ratio of moles of base to moles of acid has to equal this ratio, which I calculated in my Henderson-Hasselbalch. So basically what I have now is a proportion. And when I have a proportion, the way that I can solve for my unknown X is I can cross multiply So I'm going to cross multiply my 0.1x times 0.630957. So that's right here. And then I'm going to cross multiply this 1 times 0.0120 minus 0.12x, which of course 1 times anything is itself. So that's how I get this equation down here. Then I multiply these two values together. 0.1 times 0.630957 is 0.0630957x. And on this side, I cannot simplify any further, so I'm going to add 0.12x to both sides. When I do, I get 0.1830957x is equal to 0.0120. Now I'm getting down to business. Now all I have to do is divide both sides by 0.1830957 to get x. And I get x is equal to 0.06554 liters. Now remember, this x was the volume of acid that I'm going to use. So, and that's in liters. Everything has been in liters. So therefore, if I change this to milliliters, this is in liters, I'm going to change it to milliliters, and subtract it from 100 milliliters, I get 34.46 milliliters of base. Now, I want to be sure and check my answer. I know that my ratio of base to acid has to be this. So, and I know my molarity of both my acid and base solution. So I am going to check to make sure that this works out. If I have 65.54 milliliters of acid, that's this many moles, and I multiply it by its molarity, this is how many moles of acid I would have. And then if I have 34.46 milliliters of base, this would be its volume in liters, multiplied by its molarity, this is how many moles of base I have. So my base to acid ratio should be 0.630957, and it definitely is within the correct number of sig figs. It definitely is that. So I've checked my answer, and I can be confident that these two volumes that I calculated will be correct.